Have you ever stopped to think about how we've been slinging files across the internet for decades? I mean, long before the cloud, before you could just drag and drop everything, there was this original workhorse that made it all happen. Today, we're going to pull back the curtain on that original file mover, FTP. So here's the game plan. First, we'll nail down exactly what FTP is. Then we'll figure out where it fits into the whole network puzzle. After that, we get to the fun part, how it actually works its magic. We'll look at the good and the bad and wrap up by talking about why this old school protocol is still so important to understand. All right, let's get right into it. At its core, FTP was born to solve a huge fundamental problem that the early internet was facing. I mean, really think about it. You've got all these different computers with totally different ways of organizing files, different directory structures, maybe even different ways of just representing text. So how in the world do you build a bridge between them? How do you create a universal translator for files? Well, that's the exact question FTP was designed to answer. So the official definition is right here. FTP stands for File Transfer Protocol. It's a standard part of TCP/IP, which is basically the rulebook that the entire internet runs on. And its job, it's beautifully simple, to shuttle files from one computer, one host, to another. For a long, long time, this was the way you'd upload your website files to a server or download programs. And the mission was crystal clear. Number one, create one standard way for everyone to share files. Number two, make it easy to use remote computers so people would actually, use them. And number three, make sure the whole process was reliable and fast. Okay, so we know what FTP is, but where does it actually live inside the crazy, complicated world of network architecture? Let's take a look. So if you picture the network as a stack of layers, this is the famous OSI model, you can see FTP sits right at the very top. Layer 7, the application layer. This is the penthouse suite, the layer that applications we actually use, like a web browser or an FTP client, talk to directly. And what that means, being at the application layer, is that FTP is what provides all the specific commands and services for moving files around. It's the part of the process that lets you, a user on your machine, reach out across the network to access, grab, and manage files on some computer miles and miles away. Okay, now we're getting to the really cool part. How did FTP solve that universal translator problem we talked about? The answer is in its really clever and unique design. And here it is. This is the secret sauce. While a lot of other protocols just use one channel for everything, FTP does something brilliant. It opens up two totally separate connections between you and the server. And this division of labor is what made it so powerful back in the day. I love how this breaks it down. So first you have the control connection. Think of this like making a phone call to arrange a package delivery. It's for sending commands, right? Hey, list the files you have. Okay, I want to get that file. It's simple, and that phone line stays open the whole time you're connected. Then you've got the data connection. This is the actual delivery truck. It only shows up when you need to transfer a file. It handles the heavy lifting of the data itself, and as soon as the package is delivered, poof, it's gone. It's a really efficient design. And here you can see that whole dance in action. First, you establish the control connection. You make the phone call. Then you send your commands, and the server talks back. When it's time to move a file, the data connection opens up just for that job. The file gets sent, and then that data connection shuts right down, leaving the control line open for your next command. So cool. Now, FTP was the king for a long, long time, but nothing's perfect, right? Especially when you look at it with modern eyes. So let's break down the good and, well, the not so good. So on the plus side, FTP is fast. I mean, really fast. It's got a very streamlined design that just moves data quickly and efficiently, and it did have some basic security. You needed a username and password to get in. And of course, it worked both ways. You could upload and download files. But, and this is a huge but, the downsides are massive by today's standards. The absolute biggest problem is that everything, your username, your password, the files themselves, is sent in plain, unencrypted text. Anyone listening in can see it all. This makes it a sitting duck for eavesdropping and password-guessing attacks, and frankly, this complete lack of real security is why we've moved away from it for anything sensitive. So you might be thinking, okay, if it's so insecure, why are we even talking about it? Great question. It's because its core ideas were so influential, they completely shaped how we handle file transfers today. This quote right here just nails it. That whole two-connection model, it was a genius solution for getting all those different kinds of computers to talk to each other. It separated the organization from the actual work, and that created a really robust system for its time. And this is its real legacy. While we don't really use plain old FTP anymore, its DNA is all over its modern, secure descendants, like SFTP and FTPS. You can think of FTPS as classic FTP wearing a modern coat of encryption. SFTP is a bit different. It's a whole new protocol built on a secure foundation from the start, but both of them exist for one reason: to fix FTP's original fatal flaw. And that brings us right back to our final question. Why study this old, insecure protocol? Because you can't really understand why our modern, secure systems work the way they do without understanding the problems they were built to solve. FTP is a cornerstone of internet history. It doesn't just show us where we started, it shows us exactly how far we've come.